The following contains excerpts from the Caribbean Educator's Guide to Computational Thinking for Kindergarten to Form 5. You can pre-order your copy at 51books.com. I hope you are blessed by it.
Welcome to our second lesson, where we confront a fundamental truth about computers, their limitations. In an age where technology seems to have no bounds, it's crucial to understand that even the most advanced computers have their constraints. Indeed, this is a truth that we should start teaching children from an early age. That said, what follows in the rest of this lesson is better suited to upper primary and secondary pupils. Let's begin unpacking the concept of intractable problems. In computer science, an intractable problem is one for which there exists no efficient algorithm to solve it. This means that no matter how powerful our computers become, certain problems remain beyond their reach. To address an intractable problem, computer scientists work on heuristic solutions. Heuristics involves using practical problem-solving techniques to arrive at the closest possible solution in a reasonable amount of time. A classic example of an intractable problem is the traveling salesman problem, TSP. Imagine a salesman tasked with visiting a list of dispersed locations, each only once, and returning to the starting point while minimizing travel distance. Seems simple, right? But, as computer scientists have discovered, finding the most efficient route for the salesman to take is anything but easy. To help your students understand the difficulty of the TSP, we have provided you with our downloadable Traveling Salesman Problem Unplugged activity. It's 3 pages that can be printed in black and white or color. You can have them work individually, print just a few, and have them work in groups of 2-4, or simply show pages 1 and 2 on a screen, and distribute a copy of page 3 to each student. On the first page, we meet Sean the shoe salesman. We see Sean's client list, a list of shoe stores that he needs to visit at different locations in one big geographical area on a map. We see where each store is in relation to his home. And then we're presented with the big question: what is the shortest route to take to visit each of these locations once? On the next page, we see how the problem becomes even more complicated when you have to consider obstacles such as topography, buildings, parks, roads, bodies of water, forests, and farmland. Then on page 3, students have an opportunity to start making decisions as to which shop he should visit, at what time to come up with the most efficient route. That said, page 3 presents realistic logistical considerations. For example, the owner of the Fab Feet store in Guava Grove is only available from 8 a.m. to 10 a.m. to meet with Sean. At She Shoe in Coconut Hill, Sean has a 2:30 p.m. appointment. Spendless Shoes, which is near Sean's home, only takes appointments after lunch. These kinds of logistical details further complicate the traveling salesman problem. Having the students do this activity with a time limit for completion will help them to know firsthand the difficulty in this seemingly simple question. Having been a salesperson myself, I know this challenge all too well. To illustrate the magnitude of the TSP for computers, consider this. Even with the world's fastest supercomputer, it would take an incomprehensible amount of time to compute the optimal solution. We're talking about billions of years. The actual number is noted this way, a number so vast it's beyond human comprehension. This astronomical time frame underscores the impracticality of solving certain problems computationally. There are a few other famous intractable problems. For example, you can learn about the knapsack problem in the Stanford University lecture slides via the link under further reading. As we wrap up our discussion on the limitations of computers, let us acknowledge the importance of humility in the face of complexity. While computers have revolutionized our world in countless ways, there are still frontiers beyond their reach. In our next lesson, we will delve into the concept of computational thinking, exploring how we can harness human intelligence to tackle many challenging problems. Until then, check out the link under further reading to learn more about heuristics as you consider the profound implications intractable problems hold for the future of technology. Thank you.
If you use these lessons and tips, please give me some feedback in the comments about what age group you taught and how it went. Also, please like and share this video with other teachers and help us empower more educators across the region by subscribing. Thanks for watching. Bye for now and God bless you.